So let's continue talking about bijections, but now let's look at this result, Theorem 10.8, which says let A and B be finite, non-empty sets such that the number of elements of A equal the number of elements of B, and we're going to let F be a function from A to B. Turns out then F is 1-to-1 if and only if F is onto. So it turns out if your sets are finite and they have the same number of elements, if you know your function's 1-to-1, then it has to be onto. And also the converse, if your function is onto, it has to be 1-to-1. So let's go in a little bit on the proof here and discuss how the proof is going to work. So let's suppose A and B have n elements in them, and we're doing with an if and only if. Remember, there are two parts. So part one, we're going to assume F is 1-to-1, since the n elements, if it's 1-to-1, then your elements have distinct images. What we learned is there are n distinct images. Well, because B has exactly n elements in it, this means that the range of F, or really the image here, is B. So maybe they'll say this instead, I'll say the image of A is B, therefore F is onto. So this was going in the forward direction. Now let's go in the backwards direction. So now we're going to assume F is onto. That means that each of the n elements of B is the image of some element of A. Well, that means that consequently the n elements of A have n distinct images in B. So I'll say this implies that no two distinct elements of A can have the same image, because if they did, then there would be some element of B that wouldn't be the image of an element of A. So F is 1-to-1. All right, so now let's define a new function. So I'll say for a non-empty set A, the function I sub A, which is a function from A to itself, defined by, it just spits out, if I plug in A, it spits out A for each A and A is called the identity function of A. So let's look at an example here. Let's let S be the set 1, 2, 3. Then the identity of S, which is sometimes we leave off the S if we know what set we're talking about. Well, the identity is going to map 1 to 1, 2 goes to itself, 2, and 3 goes to 3. And in the end, the identity function, so if we look, maybe I'll do a picture here for this case. Here's 1, 2, 3. 1, 2, 3. This is S to S. The identity function is a bijection. And this is true in general, not just in this example. So I'll say the identity function I sub A is bijective for every non-empty set A. So no matter what your set A is, the identity function is always going to be 1 to 1 and on to, it's always going to be a bijection.